Hi everyone. We're going to go ahead and try to get going on balancing chemical equations. I'm going to break this down into two different videos for this one. Both of them will be quite short and hopefully very easy to follow. The first of the two, I want to look at just one compound at a time, break it down into the elements that would be present and how you know how many of each element you actually have. I also want to introduce what a coefficient is during that video as well, if you haven't heard that. The second video will go into the parts of a chemical equation, such as reactants and yields and products, and how you go ahead and actually balance both sides of the reaction so that you can tackle any balancing chemical equation problem that you might have. All right, so let's go ahead. All right, so here's our first example, Fe3O4. So what we need to know is that we have both elements and numbers here. So the first thing I would like to do is figure out what elements are present. In order to do this, you really need to look for the capital numbers that are in your compounds. So for instance, you start your compound here with a capital F, and then a lowercase e, and then the O becomes capitalized again. Once you have a new capitalized letter such as the O here, that means you have another element. So let's go ahead and write down that we have an Fe, at least one, and at least one oxygen here. The numbers are what's going to tell us how many of each one we have. And the numbers will fall to the right-hand side of your element symbol, such as the 3 is going to correspond to how many Fe's you have. So we have 3 irons. And this 4 is going to correspond and go back to the O, which means we have 4 O's or 4 oxygens. For our next example, BaO, it's a little bit more difficult because we have no numbers, kind of breaking things apart. And we also need to know what the no number actually means. So let's go ahead and break down what compounds we have here first, and then we'll go into those numbers. So again, looking at the capitalization, we have a capital B and a lowercase a, and all of a sudden the O comes in as a capitalization again. So our first element that we need to be aware of is Ba, and the second one is O. So just go ahead and get those written down, and I'm just going to put my dashes in now so that we can figure out what number we have of each of them. So just like the last one, we should really have numbers to the right-hand side of each one of our elements, but there's nothing there. When there's nothing written in that space, in chemistry, just like in algebra, there means there's a 1 there. So let's go ahead and get a little note jot down about that. Alright, so we have that little note written down now onto your right-hand side. And it's nice and starred. So if there's no number written, then it is 1. So, in this case here, just like our little green circles have, there's no number there. So both barium and oxygen should have 1. Because remember, the number to the right corresponds to the element that's on the left-hand side. So let's go ahead and get both of those written in. And that's all we're looking for. So here's our next example, and we have parentheses, which are new here. So let's go ahead and work through and see how those are going to be incorporated. We still want to list our different elements, which we have Pb, N, and O. And so the Pb is not inside the parentheses, so that's going to be treated just like we have been doing. There's no number to the right, which that means there's 1 Pb. Then inside our parentheses, we still are going to do that like normal. However, whatever the numbers are, so we have a 1 and a 3 here, we need to multiply this 2. And so for those of you that are kind of a little bit more math-minded, we're going to distribute the 2 in. So we're going to go ahead and do 1, since there's no number there, 1 times 2. And then this one will then be 3 times 2. And whatever that answer is, that's how many of that element you have. So we have 2 nitrogens and 6 oxygens. Okay, we're going to throw another something a little new at you, and here is where the coefficient is coming in. So if you ever find a number that is in front of your compound, that is referred to as a coefficient. So you'll go ahead and do the compound itself that you have right here, just like normal, and then the coefficient is going to go ahead and multiply everything by whatever that number is. So let's go ahead and do this first. Breaking this down, we should have a carbon, a hydrogen, and an oxygen. Each one of those is capitalized, so hopefully that's pretty easy to point out after we've done a few. The number to the right of carbon is 2. Number to the left of hydrogen is 2. The number to the right of oxygen is 4. Now what to do with that 2? So this coefficient, 2, is just going to multiply all of these numbers by 2. So by 2, by 2, and by 2. So really, altogether we have 4 carbons, 4 hydrogens, and 8 oxygens in this part. For all the other examples that were before this one, there was no number here. And when there's no number, it just means there's a 1. So there's no extra work when there's no number that's in front. This coefficient is going to become really important when you start balancing chemical equations, because this is what's going to allow us to actually balance it. All right, here's our last example. Now you need to notice this little dot here in the middle. This is just a notation. It is not a multiplication sign. It's a sign that we have something called a hydrate. And so when we hydrate ourselves, we are normally drinking water, and that's what we have off to the right here. So a hydrate is just a compound with some water with it. So we can go ahead and treat this as 2 separate problems, and then at the end, if there's anything that's in common between the 2 of them, just add them together. So on the left-hand side, we have an Na, we have a C and an O. The Na has a 2 to the left, the C has no number, so 1, and your oxygen has a 3. For the left-hand side, that's all that we need to do. But for the right-hand side, we have an H and an O. We have 2 H's and 1 O since there's no number there. We have a coefficient on this side, so we need to multiply both of these numbers by that coefficient. And so now we really have 20 hydrogens and 10 oxygens. Before we say we're done, we have 2 oxygens on either side, and we really need to add those together to really understand that we have a total of 13 oxygens. Just add them together. And those are our 5 examples, and now we're ready to go ahead and break down what a chemical reaction is and how to balance it.